everyone. Welcome to another episode of Radar, the podcast that takes you into the world of Safran and looks at all the issues that affect the group on a daily basis. In this new episode, we're exploring 3D composite materials, and more specifically, how they were created. At the heart of this major innovation, which allows us to produce lighter and stronger parts, is a man who never gave up against all odds. And this man is our guest of the day, Bruno Dambrine, an honorary expert in composite materials for Safran. So listen up. Today we're taking a class in perseverance. Hello, Bruno Dambrine. Welcome to the podcast.
Hello.
So today we'll be telling our listeners the story of 3D composite materials, specifically 3D-woven carbon fibers. Now, are we talking about actual weaving here, or maybe you can tell us exactly what is the 3D weaving of composite materials?
3D weaving of composite materials is a particular part of composite in general. Usually, composites are made of thin layers that are stacked together to make a part with fiber and resin entrapped. And then after a cure cycle, all is consolidated by polymerization of the resin. This is a process that induces you have to stack a lot of layers, which are very thin, less than millimeter, 100 of microns. And with the 3D weaving, the idea was to reduce this time of stacking by making a preform by using classical techniques of weaving like jacquard, which is used from the beginning of the 19th century, to make preform in which the fibers are interlocked, that are named ply-to-ply interlocked, to form a preform, which has the shape of the final part, in which we introduce the resin by injection. And then after, with a cure cycle, we have the part done in one shot. That's the main difference with the classical composites, which are named laminate.
Well, it sounds very sophisticated. This technology started emerging in the early 90s. Tell us, why did you take an interest in it?
Composite was very promising because of the ratio of weight to performance that was very high. But in this time, it was very difficult to make for engines or for aircraft because the process was not sufficiently mature to address the certification process. So it was still evolving in different ways. Of fibers were not stabilized and the process were a little bit complicated. So the introduction of composite materials was delayed until it starts with the aircraft, but with the classical laminate materials. At this time, Safran was trying to look what it would be interesting to do, and the most interesting was the front parts of the engines, mainly the fan blades, which are rotating and so on. And programs were everywhere on all the engine manufacturers were trying to make fan blades with composite. And with this process, Safran was in the way to test some, and at the size of the CFM56, which was the aero engine leader of Safran, results were very bad, mainly for the forest object damage results when we were ingesting birds that we are obliged to certify with. So we started to make a pause with that and start to think if another way should be possible for the next products of Safran, like the LEAP. 3D weaving was potentially interesting because of the damage process, which was not within the layers, but with the volume. That's why we started to try to test and develop this technique.
Okay, so the technology is really promising, but the results are not up to par, not certifiable yet. Snecma decided to stop working on composites in 1996. So at that point, what did you decide to do?
At this time, I had a meeting with the technical director of Safran to status on the capability of these materials, if they were promising or not for the future. And I convinced him to continue only academic research with that, not involving Safran directly, but by suggesting subventions or proposal of work. The intent was to maintain an efficient network of research for this technology.
Well, yeah, so you found a loophole by taking it out of the business side and putting it into the academic research side so that you guys didn't stop.
Yeah, because if you want to innovate, you need to have a large background of results. And so in end of 1999, Safran decided to have a new look at this technology. So they asked me to make this work at this time. And at first, as I was more a mechanical engineer than an expert in weaving, I went to SCP, which was a subsidiary of Safran at this time, where they had weaver engineers in Bordeaux. And I met Dominique Coupé, which has been in this work from the beginning and which was expert in weaving. And we has been able to find weaver that was able to make the products we intend to do. And we had the technology to drive jacquard, but electronically and not mechanically as in the 19th century. This weaver was Albany, which was in the US, close to Boston, with a very short team. We were only Dominique and myself on Safran side, and John Goering and Brian Coffenberry on the Albany side. And we started very quickly as we were on the same page on the mechanical and the way to solve the problems. So it was very, very fruitful. It was a lot of travels to Boston because at this time you have to be face-to-face in this phase of program. And we were very efficient in making the demonstration of proof of concept, this small part of demonstration of different parts of the blades. Then at the end, you have to assemble that to make the part you want to test. And that's what we did during these 2 years.
So this is fascinating. You're really bringing together two different expertise. We have weavers from the United States and mechanical engineers from France coming together to create this new technology.
Yes, it's absolutely a mix of all this. The mechanics is linked to the weaving, and the weaving depends on the mechanics of the part. So you have to be on the same page to work properly on that.
So as I understand it, this collaboration with the Americans allowed you to develop the project until the inauguration of a joint Safran Albany plant in April 2014. So after years and years of research and travel and tenacity, because you guys overcome a lot of challenges, you guys were able to create this joint venture.
Yeah, it was really fascinating to success in this way. And we had the support of technical management from Safran. Pierre Toureau and Jean-Paul Herteman, which was at this time the CEO of Safran too. And it was very efficient to have only report to these people. So I should say short team, which at this time was bigger and bigger. I think more than 600 people now working on this subject. But the basics were demonstrated by a small team of 4 people. And then after, work is bigger and bigger. You have to convince and certify, which is very important for us.
Definitely, to bring it to the market. So
yeah.
Now, fast forwarding to today. I mean, obviously, composite fibers are no longer just in academics for Safran. You've brought it back to the business side. How are composite fibers used in Safran projects today? And what advantages do they bring to the table?
The main advantage at first was the weight saving. More than 500 kilo per aircraft for the 737 MAX. There was also an efficiency in aerodynamics because of the number of blades were reduced consistently from the CFM to the LEAP. And this was a large part in the fuel savings, more than 15% of the LEAP compared to the best version of the CFM. And the fan case too, that were introduced after the fan blade. It's a large contributor to the weight saving for the LEAP engine. 3D composites are mainly used by Safran aero engines for the LEAP. The efficiency also of the engine was improved by reducing the number of fan blades, which was possible because the material was lighter. And this led at the end with the fuel savings of more than 15% currently to the base version of the CFM56. And it's really a big advantage for Safran, which is the only one to have this technology, because intellectual property has been really very developed with more than 150 patents developed worldwide. And with these materials now, there is a preparation for the next future engines because we are always progressing. So we'll have a large part inside, but now we have to think to introduce that in other companies of Safran, subsidiaries. Many applications are also possible.
I love that you brought up the future because, as you mentioned, so you guys have 150 patents already. So in your opinion, you think this technology can evolve and be improved even more to be applied to other parts or other business units?
Absolutely. And for this, one thing important was created too in 1999, as I remember, was Safran Composite, which is an excellence center for all the Safran group to introduce composite materials, which is now efficient and is able to propose weaving. And the extension to the hot parts of the engine, for instance, with the ceramics. Now, ceramics matrix composite are also an alternative for high temperature parts and will be more and more easable to do with the 3D weaving. And 3D weaving of ceramics is also something I think Safran is really at the top.
Well, it's so exciting and innovative, and I'm sure we'll all follow along to see how this evolves. Thank you so much, Bruno Dambrine, for being our Radar of the Day. We'll see you soon for a new episode of Radar.